Okay, so I will start talking about our hardware part for Group 11. This one is the overall picture of the two controller. One is the laser gun, the other is just solely for motion. Same thing, same. The center one is the vest. Yeah, so each player will have one IR receiver and one IR transmitter. The transmitter is here. The transmitter is here. In a gun, then the IR receiver is on our vest. This one, the center is the vest. The right one is the gun. So we choose KY022 infrared IR receiver module and KY005 IR transmitter module. Because for the receiver module, the power supply is quite it fits the Arduino Beetle, and also it has a small size and lightweight, and it has a sampling frequency about 58k hertz, and a very small analyzed delay for real-time cooling. Then for the infrared IR transmitter module, it's also because its power supply is small size, and also it has an effective range of around 5 to 10 meters and the effective angle about 30, which is quite sufficient for our project. For range, anxiety, and accuracy, first of all, we use a LiPo battery to provide stable current and stable power supply to the Arduino Beetles to ensure that the reliable operation of the IR transmitter and receiver, to ensure that at least a 3 meters range for the IR transmitter. And we also use simple encoding, like we use an uneasy encoding, and we check the address of that signal. If the address matches with the address we set in the in our gun, then we will do the following operation. So this one is the feedback system for laser gun. Basically, it has a light. This one is to signify the calibration. When it turns green, it shows that the calibration succeed. Then you need to do a star move. Then it shows all the bullet. 6 bullets here. You got one button at the back. You press the button, 1 bullet is consumed. 3, 4. Then for the vest, feedback. It has a LD bar, which shows the total health. 1 LD bar represents 10% of health. If you see, if you see the LD bar is blinking, as you can see here, which means that only 5% of that health is consumed. So in this situation, there are 95% of health. Then if it is completely not blinking at all, it will be 90%. Here's 85%. And 80% extra. For the completely integration of the game system, it's just a function that we take in a variable and do the following things. This one is for vest. For action shot and normal shot, we have different damage. Then based on the message we get from our game engine, then we can do the corresponding changes to the global variable. This one for gun is the same. If a reload bullet message is received, we just trigger this function. This one is for the controller, the right hand controller, which is the gun. And if you cannot see, because the MPU we use is actually at the back. Yeah, it's somewhere here. So why we choose MPU? It's because of the power supply and small size and lightweight. And also the sampling frequency is around 1k hertz, and it has a 3 axis of accelerometers and gyroscope, which is quite sufficient for motion detection. And also the last one, data can be sent at up to 50 hertz, so enough for our project. So start of move. Simply, the start of move is just to check whether the value is check the value of acceleration in a 3 direction. Does it exceed some the certain threshold value? If that exceed that value, then the code will be changed from idle state to operation state. You can see here. So after that, the controller will start working. Later I will show a full demonstration. Then about data preprocessing. So we did a calibration of MPU at the start. Yeah, so we take the average value of around the calibrated sample number, the average value of that, and we minus that to make it 0. Everything is 0 at the start. Also, we did some a Boolean function to check if the value is within some motion threshold, then like for example like 203, then we decide not to send it to our internal comms. So yeah, since most of the time it's just a noise, the controller is not moving, so you can see it's large enough value will be sent, will be printed out. Yeah, this one is the overall setup. Then it's the complete system. How does it work? So at first, we pressing the switch to switch on the controller, the gun. Then wait for a red light. You can see here. Wait for a red line to light up. If it's showing a red line, means that it's calibrating. Then it take about 4 to 5 seconds. Then you see a green light blinking, which means that it's all ready. Then you do a start motion. When you do a start motion, then the machine catch that. Then the bullet will start loading. 1, 2, 3, 4, 5, 6. When you start loading 6 bullet, you can do the action shoot or any shoot. So this one is at least, I think it's 3 meters. If you press, I press a button. I press a button just now. Then you can see the red line blinking. Here. See a red line blinking, which means it's being shot. Sorry, I didn't show the red light blinking just now for the vest feedback system. So basically, if the vest is short, it will show a red line to signify a bullet landed. One shot. Second, then the third. Then for the power system design, this one is all the voltage and current and average power for each of the components. So after the calculation for the vest, it's around 300 MW total power consumed. So it can last if we I use a 3.7 voltage 101k mAh battery, lithium battery. So it can last, the vest can last around 12 hours. And for the gun, it can last around 6 hours. But if you consider the voltage drop when the capacity of the battery turns low, I think this value need to be halved, but still sufficient for 20 to 30 minutes demo. So why we choose a lithium battery? Because it provides a stable current and voltage. Also, it's very small. It's very small. Can fit into our gun controller, I think, and also it's quite easy to charge. I think that's the whole part of my hardware.